look at function notation. Function notation, so how we denote that we're using a function and working with that. So function notation, put slash evaluating functions. So a way that we can use this notation. So what we, kind of the main idea is that instead of using y, we use f of x. Now, so I'm writing this, I'm saying f of x, but this is how this is written, f parenthesis x and parenthesis. But we read this as f of x. And what this is really saying, this is the value of the function at x. The value of the function at x. Is the way that we'll do an example, and I'll explain that a little more. So the example we're going to do, let's say, normally we just have a regular equation of, let's say, y equals 2 minus 5x. So there's an equation. So now, if we were asked to rewrite this in function notation, we would say that f of x equals 2 minus 5x. So that's the same thing. F of x and y are the same thing. It's, y, remember that's the dependent variable. Now we're just using f of x as this. So let's start off with doing an example with this. So let's say I'm asked to find f of 2. We're kind of still in the same example. Find f of 2. So what this is saying is find the value of the function when x is 2. So even though we don't see the x now, instead of f of x, now we know that x is 2. So every time we see x here, we would plug it in. 2 minus 5 times 2. Or 2 minus 10, which is negative 8. So now we kind of read that as the value of the function at 2, the value of the function at 2 is negative 8. So that's how we can read it. So I kind of going to rewrite f of 2 over here. So f of 2 is negative 8. So notice one reason this is helpful is that it preserves the value of what x is. So in this statement, I know what x is and I know what y is. Okay, and I'm going to sketch this real quick. A little side over here. Y equals 2 minus 5x, maybe it makes sense to first rewrite it. Negative 5x plus 2 in my mx plus b format. Y equals mx plus b. So I know that I would start at 2, and I would go down 1, 2, 3, 4, 5 over 1. Down 1, 2, 3, 4, 5 over 1. So here's my line. Should be straight. Imagine it's straight. Okay, so there's my line. So this is kind of just, it's stating that when x is 2, right here, the y value is 8. So notice that point right here, that's negative 8. So that's the point 2, negative 8. So this is just showing that that's the value of the function. The y value is negative 8, or the function value is negative 8. Okay, let's do another one. Find f of, let's do negative 1. And looking at the graph, it looks like it should be somewhere up here. So at x is negative 1, the function is going to be up at maybe 6, 7. Let's see what happens. 2, so when I plug in negative 1 for x, 2 minus 5 times negative 1, so I've got 2 plus 5 is 7. Okay, so there's that point, negative 1, 7. So just with function notation, this is just saying the value of the function at negative 1 is 7. The y value is 7. Okay, let's go a step further. So here I just plugged in numbers. I evaluated the function with these numbers. Now we're going to keep using that same function, so let me rewrite that. So continuing with our example of f of x is 2 minus 5x. Okay, now let's do f of negative x. So now it's not a number that we're evaluating a different form of x, in this case negative x. So that means, so here I have x, here I have x. So every time now that I see x on this side, I plug in negative x. So 2 minus 5 times negative x. So this is going to be 2 plus 5x. So we're still going to have an x in it because we're evaluating it with an x value, but this will be used later on. We'll see some different reasons why. Here's another one. How about f of x plus 2? So the function is f of x is 2 minus 5x, so I have an x here, have an x here. So whatever I'm replacing, whatever I'm putting within the function right here, what I'm doing f of, in this case f of x plus 2, that means I plug in x plus 2 right here. 2 minus 5 times x plus 2. Now I can do a little simplifying. Distribute the minus 5, so minus 5x minus 10, and let's combine these constants. It looks like negative 5x minus 8. So if we can, we would simplify.